Okay, so let's start with this. We have 3 pi over 2. We're going to take this. This is from example number 3 in the book. We're going to take these coordinates right here and change them into rectangular coordinates. These are polar coordinates. That's an r and that's a theta because it's a polar coordinate. Now, if I wanted to find the x and the y, we're going to use these guys right here. Because that's how you define x, that's how you define y. Straight from the unit circle stuff that you guys know. So if I want to find x, I'm going to take the radius, which is 2, and take the angle, which is 3 pi over 2, and just plug it in. Okay, you guys can figure that out. 3 pi over 2, cosine of 3 pi over 2 is 0. 0 times 2 is 0, so your x is 0. And what's my y? My y is going to be 2 times sine of theta, and that's 3 pi over 2. Sine of 3 pi over 2 is negative 1. So they have negative 1 times 2. That'll give you negative 2. And so my y equals negative 2. You guys good? Yeah. No problem? Okay. Here's another one, but this time it's with a negative 8 and a pi over 3. X equals negative 8, and then we would go cosine of pi over 3. What is cosine of pi over 3? Nasty. Yeah, that one's 1/2 times 8 over or negative 8, which would be negative 4. So this is r and theta, while my x would be negative 4, and what's my y? So I plug in all my stuff again. So we have sine. What's sine of pi over 3? Rad 3 over 2 times negative 8. So that 2 is going to cancel out with the negative 8, so we get negative 4 rad 3. Negative 4 rad 3. Okay, so that's going from polar to rectangular. I'll finish this next one. Alright, the next one's going to go from polar to rectangular. So here's our first one. No, rectangular to polar, sorry. So we have 1 rad 3. This is from the example 4. So this is now x and y. So we're in rectangular form. We need to have it in polar form. Do you guys know where this point would be on your graph? 1 and then up to, I don't know, rad 3.
A little under 2.
Right? Yeah, it's just a little under 2. So that's where the point is. If you can see the point on a graph, or like which quadrant it is, you can kind of see like what the angle is going to be. You know the angle here is going to be less than pi over 2. So how can we do this? Let's see. We have this formula, x squared plus y squared equals r squared. Okay, so we have an x, we have a y. This is how we're going to find our r. And then there's the other one, the tangent one. The tangent of theta equals x, I'm sorry, not x, y over x. So all we have to do here is plug in the x's and the y's to find our other variables, the r and the theta. So for the x, we're going to plug in 1, so it's going to be squared. And then we're going to plug in, rad 3. That's going to be squared also. And then we have that equals r squared. So this is going to be 1 plus 3 equals r squared. And then so that's going to be a 4 right there equals r squared. We square root both sides, it's going to equal, r is going to equal 2. Now normally when you square root, you use that as an inverse operation inside of an equation, your answer is going to be plus or minus. However, because it's the radius, we're going to say that this is a positive distance right here. So that's a distance of 2. That's just one of the conditions. Whenever you're changing a rectangular set of coordinates into polar coordinates, the r is always going to be positive. Okay, so let's see. Let's write our answer down here. The r is going to be 2. Now we just have to find our theta. All right, so to find theta here, we got to plug in the y and the x. So we have tangent of theta equals, now our y is rad 3, and our x is 1. So it's really just rad 3. Now, can you think of a rectangle? I'm sorry, not a rectangle, a triangle that gives us this. It gives us a red 3 right there and a 1 right there. I personally can't think of one right now off the top of my head. Some of you guys know you have this memorized because you memorized the unit circle, and so you know what theta is just because you've memorized it. You know what gives you a rad 3 for tangent. But if you didn't, what would you do? Well, I actually don't know where I was going with this. Because if we do this, we're just going to get a 2 right there, and this doesn't help us. Oh, wait. No, actually it does. Now this is with a radius of 2, which we've already found. But in our unit circle, this is supposed to be a radius of 1. So if we divide everything by 2, we divide this by 2, and we divide this by 2, and this by 2, now we have 1/2 for our x, rad 3 over 2 for our y, and 1 for our radius. Our point right here, if this was in the unit circle, would be 1/2 and rad 3 over 2. And hopefully that jogs some kind of memory. Cosine of this theta, right here, this theta, is going to give us 1/2. And cosine of this theta is going to, I'm sorry, the sine of the theta is going to give us rad 3 over 2. And so what theta gives you those values for sine and cosine? And that is pi over 3. So there you have it. That's those are your polar coordinates for this rectangular set of coordinates. Now let's try the one from example 5. Example 5 is also going from rectangular to polar. So let's see our rectangular coordinates here. So our rectangular coordinates for this one are -2 and 0. So because these are rectangular, we know that this is x and y. If we try to visualize this first, we know that -2, 0 is right here. That's -2, 0. It's on the axis, and so finding this out, finding the polar coordinates out for this one is actually a little more simple. We don't have to plug in everything because we can see what the distance is right here for r. So we're going to put 2, and we can also see that this angle right here, this theta, is going to be pi. And so that's all the work we have to do for that one. If you wanted to go ahead and plug in everything to the other formulas that we were using, you can go ahead and do that, but it's not really necessary if you know where the point is on the graph, or if the point is on one of the axes. It makes your job a lot easier.